Welcome to this video on completing the square. I'm going to tell you how to do it, and then I'm going to do some walkthrough examples and give you a question at the end. So the basic principle is to get ax squared plus bx plus c, or the quadratic, in the form bracket px plus q close bracket squared plus r, or p bracket x plus q squared plus r. So why do we need this? Well, to solve and get the roots for a quadratic that cannot be factorized. Normally you would just factorize it and then find the values of x. For example, if you had x squared plus 4x plus 4 equals 0, this could be factorized into x plus 2 squared equals 0, so x would be minus 2. But if you have x squared plus 8x plus 10 equals 0, this can't be factorized. So here we would go about using this method called completing the square. So how do we go about doing this? Well, the form we would usually use is p x plus q squared plus r. So for p, you would factorize the coefficient of x squared out of ax squared plus bx. So the coefficient of x squared is a. So if we had 3x squared plus 6x, this would be 3 bracket x squared plus 2x close brackets. For q, you would halve the coefficient of x over p. So moving back to our example, we have 3x squared plus 2x. We would halve the 2 and get 3x plus 1 all squared. And finally, for r, you would take away q squared times p. So back to our example, 3x plus 1 squared minus 1 squared times 3. So the answer would be 3x plus 1 squared minus 3. So 3x squared plus 6x in the form of the completing the square would be 3x plus 1 squared minus 3. So back to the example, we have x squared plus 8x plus 10 equals 0. So if p would equal 1, as the coefficient of x squared is 1. So we'd write that down, x squared plus 8x plus 10 equals 0. Now for our q, we would halve the coefficient of x, so that would be 4, and we would, for r, we would take away q squared times p, so minus 4 squared. So now we have x plus 4 squared minus 16, and don't forget the 10 at the end, giving us x plus 4 squared minus 6. So how do we actually solve for the roots? So to do this, we would rearrange for x. So let's say we have px plus q squared plus r. We would take away r on both sides, then divide by q. Then we would square root both sides, and then we would take away our q on both sides. So for our x squared plus 8x plus 10 equals 0, remember the form we put it in, x plus 4 squared minus 6 equals 0. Add 6 on both sides, square root both sides, and take away 4 on both sides. Now as you can see, if we had r and q both being positive, we wouldn't actually have any roots because we can't square root a negative number. And this will be fine. It's not something that's wrong. So we have 16x squared minus 8x plus 11. So take out the 16. Then we would halve the coefficient of x, so that gives us a quarter, square that, then take away q squared times p, and just expand this, leaving us with 16x minus a quarter squared plus 10, or due to laws of indices we have 4, we can write 16 as 4 squared, so leaving us with 4x minus 1 squared plus 10. Another example, 3x squared minus 24 plus 30. Take out the 3, half the coefficient of x, take away q squared times p, and then just continue to simplify. And now we can solve this, so add 18 on both sides, divide by 3, square root both sides, and add 4. So feel free to pause the video now. Okay, I'm going to go through it. So we would take 4 out, 4x squared minus 8x minus 9. Then we would halve the coefficient of x, so that's minus 4, and take away q squared times p, which is 4 squared times 4. Then we would continue with this, so 4 squared is 16, times 4 would give us 64, and take away 9 equals 0. So simplifying this, 4x minus 4 squared minus 73 equals 0. So to solve this, we want to get rid of the minus 73, so we add 73 on both sides. Then we want to get rid of the 4, so let's divide by 4 on both sides, and this gives us this. Now we want to square root both sides, and this would be the square root of 73 over 4. But because 4 is 2 squared, we can just put the square root of 73 over 2. And then we would add both sides. So 4 plus minus square root of 73 over 2, giving us the two solutions needed to solve it. Thanks for watching. I hope this video has been helpful. Feel free to leave any suggestions down below. Don't forget to like and subscribe, and bye for now.